Is there other life in the universe? That is what we hope to answer in this chapter. And the answer is yes. Look at that. The Hubble Deep Field. Thousands of galaxies just in the one little point in space. You literally would be insane to think that somehow we are the only life that exists in the universe. Now, there are really two questions. Is there life? And is there other intelligent life? But when you talk about the vastness of the whole universe, honestly, if you answer that with anything other than yes, I just don't think you understand the immensity of the universe. More stars than there are grains of sand on every beach in the world. How could there not be? How could just our one little grain of sand produce intelligent life? Now, before we get into the question of life in the universe, I thought it would be helpful to go through what's sometimes called the cosmic calendar. This idea was, I don't know if it was Carl Sagan's original idea or he just popularized it with the original Cosmos series. But we can think about the history of the universe going through from just the particles in the early universe before stars to the development of galaxies and stars to eventually planets, and then follow the evolution from chemistry to biology right up until the point where life has been produced that's complex enough to have culture and communicate in the ways that we do. But let's go back and let's look at this in a calendar sense, the way Carl Sagan did, the way Neil deGrasse Tyson has done recently. We're going to look at the beginning of time, the Big Bang, 13.8 billion years ago, as the first day on the calendar. Okay, New Year's Day, just after midnight. And then today, the present day, is going to be December 31st, New Year's Eve. We're going to compress all the history of the universe into this calendar so that each month is just about 1 billion years of time. Each month represents about a billion years, a little more than a billion years of time. So on that scale, here we go. The Big Bang, we know, occurred 13.8 billion years ago. And we started talking a little bit about the idea of a multiverse and how this Big Bang came about in the last lecture. But that's the time that we're pretty confident in, the 13.8 billion years. Now, that's January 1st then, of course. And we know that in the first, few seconds on this calendar is when you had inflation and the first, helium fusing and things like that. A lot happened in the first few seconds of the calendar. But in the first 2 weeks of the calendar, it's dark. There are no stars yet. Up until maybe around January 15th on this calendar, you don't actually have stars. And the first stars ignite, and that ends that sort of dark ages there of the universe. And once stars form, gravity starts bringing them together in little cities of stars. And of course, those first galaxies were not as large on average as today's galaxies because over time, galaxies have merged. But anyway, the first galaxies were forming throughout mid-January through, March. And our own Milky Way, we think, is about 11 billion years old, which would put us sometime around March 15th for the formation of our Milky Way galaxy. Now, billions and billions and billions of years go by, and galaxies form, and the universe, of course, is expanding and getting less dense. And sometime around August, the end of August, the beginning of September, our sun forms 4.6 billion years ago. And of course, the sun has a little bit of leftover debris that becomes the Earth and the planets. And our Earth is a molten ball in early September. The oldest rocks we've ever found are about 4 billion years old. So it may have taken a 500 million years or so for the Earth to cool down enough to have a solid surface. And very early on, we believe there was water on the Earth. There's still a lot of debate about how much of that water perhaps came from comets and so forth. But anyway, the oldest rocks on Earth date to about September 16th, okay, on the calendar, on the cosmic calendar. So, when did life itself begin? Well, that's a really big question. Most scientists believe it began very, very early on, perhaps 3.8 billion years ago. Very different Earth at that point, totally different atmosphere, totally different conditions, but the very first life, which would have been just as primitive as can be, just some complex carbon molecules that learn how to replicate. That's the first life. Unless life, of course, came from elsewhere. That's another thought. Maybe we're all Martians. Who knows? Did life start on Mars and come here, start elsewhere and come here? We just don't know that. And we don't know how it began. There are lots of theories. Did it begin in the in some shallow, warm pool somewhere? Did it begin in the hydrothermal vents of the ocean? That's still being debated. But by October 12th on the cosmic calendar, we know at some point photosynthesis began. A big moment in the history of life. Around November 9th, we start having complex cells that have the little, mitochondria, different things inside the cell that work together to form the cells that we think of today. And then a really big step came, and look at that. I mean, from 2 billion years ago to 1 billion years ago, life is just incredibly simple. Incredibly simple. For the vast history of life on Earth, it is incredibly, incredibly simple, single-celled life. And only on December 5th of the calendar do you even get life that has, more than one cell combined, sort of strings of cells that start working together. That's only 1 billion years ago. And what's happened since then is truly incredible. Sometime around mid-December, about half a billion years ago, a little over 500 million years ago, you have what's called the Cambrian explosion. You have a true explosion of life. And there are all kinds of ideas on why life would suddenly branch out so much. A lot of it we know has to do with the geology of the Earth, that things changed and maybe the atmosphere had, the increase of oxygen and so forth. Lots of different, there's a lot of debate about that, about what happened to lead to the Cambrian explosion of life. But we know from both the genetic record and from the fossil record that life flourished in a way that it never had before. And so somewhere there in mid-December, all of a sudden the stuff that we think of as life, as animals, arthropods and fish begin. Later on, of course, life leaves the water for the land. So all life at first was in the water, of course, and it leaves for the land. And look at that, on December 26th to the 28th, you have mammals, the first birds, even the first flowers. I mean, we think about the plants. It must not have been very colorful before that. And you have the first flowers very late in the game. Insects, amphibians, and of course, reptiles. And there's sort of an age of reptiles where the reptiles are really the dominant sort of species. They are the biggest. And of course, the most famous being the dinosaurs. And look at this, on December 30th, 65 million years ago, the great extinction event, the last great extinction on Earth, that led to the demise of the dinosaurs. Of course, that's still debated, exactly the timeline of that. But the bottom line is the dinosaurs are not here anymore, at least not the big T-Rexes and things we think of. The birds are really the descendants of dinosaurs. And anyway, at that point, it allows some of the smaller critters to start evolving in different ways, the mammals. And by later on December 30th, you have the first primates. The first primates that are going to be the ancestors of all of the apes and the chimpanzees and, of course, eventually humans. That's on December 30th. Well, let's go to a different scale now to look at the last couple days here of the calendar. December 31st, then, millions of years go by, and you have the first apes. Later on December 31st, sometime around, it looks like 2 in the afternoon, you have the first hominids. And much later in the day, at 10 o'clock, almost 10:30 at night, the first primitive humans, and I assume this may include, also the Neanderthals and other groups that were around, other types of primitive humans, and the first tools. One of the things that separates us from most animals, not all animals, but most animals, is the ability to use tools. Later then, on New Year's Eve, around 11:44, with about 15 minutes left to go in the calendar here, we start using fire, and modern humans really just begin in the last 8 minutes of New Year's Eve. We have the last ice age, there with 5 minutes to go, and the cavemen and so forth. We have fossil records of that. And look at this, with 2 minutes to go, we find the first cave paintings and things like that. Truly incredible. What is this? 28 seconds till midnight. Mankind, instead of just being hunters and gatherers, they start learning how to plant and harvest crops. Really one of the key milestones in the development of mankind, and that all occurred with 28 seconds left on this calendar. So now we have to go to another level of the calendar, just looking at that last minute, really the last half minute or so or less on the cosmic calendar. The first writing. Wow, what another huge milestone for mankind. That occurs with 13 seconds left. The early dynasties of Egypt with 12 seconds left. And the beginnings in places like, in ancient Babylon, between the Tigris and the Euphrates, in that valley, you have the first astronomy and the Sumerians, and developing the very first probably constellations and things like that in astronomy. The use of the wheel with 11 seconds left. Now that's about 4,500 years ago. And the first alphabet. Again, just one huge milestone after another. 4,000 years ago, you start developing laws. And 3,500 years ago, as you see, the Iron Age, the use of iron, which was stronger, of course, than bronze. And we continue on. 2,500 years ago, we really start developing in ancient Greece and Rome. Science, of course, expands greatly. The invention of the number 0, I love that one, around 2,000 years ago. And of course, the breaking between BC with the birth of Jesus and AD and the time period, height of the Roman Empire, right on up to today. So look at this. In the last 2 seconds of time on this cosmic calendar, 2 seconds ago, you have the voyages of all the explorers, Columbus and Magellan and so forth, and you have the Renaissance in Europe, this flourishing of art and music and science, all of that with just 2 seconds left on New Year's Eve on the cosmic calendar. And with 1 second to go, both world wars and the invention of airplanes and cars and computers and the internet, everything is really just in the last 1 second of time on this cosmic calendar. And that brings us to the modern world we live in today. What will the next cosmic calendar look like into the future? It's just really mind-boggling to think about how fast the pace, the acceleration of mankind's development has been, and what it may lead to. We're going to talk a lot about that in this chapter. Thanks for listening.